So,
Okay, good morning to one and all. Good morning to one and all. Now we have to continue with the next part of your paper 1, unit 1, chemistry 1, unit 1. Just I am sharing the screen. Okay, is it visible?
Yes,
yes,
sir.
sir.
Yes, sir.
Okay. See, we have to see the basic assumptions of the kinetic theory of the gases. First of all, we have to consider, see, gases are, you have to remember, they are randomly moving. ये दिख रही है सब गैस मॉलिक्यूल्स है, एक बॉक्स में लिया है, दे आर रैंडमली मूविंग. कंटेनर में गैस मॉलिक्यूल्स है, गैस मॉलिक्यूल्स जो है वो फिक्स स्टेट में कभी रहते नहीं, दे आर ऑलवेज इन द रैंडम मोशन. द एक्चुअल अभी उस गैस मॉलिक्यूल का जब हमें वॉल्यूम स्टडी करना होता है, व्हेन वी टॉक अबाउट द वॉल्यूम ऑफ दैट गैस मॉलिक्यूल, whatever the actual volume occupied by that gas molecule is negligible as compared to the total volume occupied by the gas. What you got this point? First assumption is that key actual volume occupied by the gas molecule is negligible as compared to the टोटल वॉल्यूम ऑक्युपाइड बाय द गैस. जो कुछ टोटल वॉल्यूम रहता है गैस ने ऑक्युपाई किया हुआ, जैसे कि ये टोटल वॉल्यूम है, इसके कंपैरिजन में गैस मॉलिक्यूल का वॉल्यूम जो है दैट इज एन नेग्लिजिबल. सेकेंड, all the molecules of particular gas are alike in all respect and have the same mass, hence these molecules are treated as point mass. second assumption क्या है? पहला हुआ negligible volume. Second, they are considered as point mass. Point mass क्यों consider करते हैं कि मैंने बताया कि they are in the random motion and they have the same mass. Okay, that's why they are point mass. Then the forces of attraction between neighboring gas molecule are negligible. This is the third assumption, is that कि whatever the attraction is there, that is an again the negligible. Fourth one, the gas molecule are in random motion in a straight line without preferred any direction. They change their direction when they collide with each other or with the wall of the container. During this collision, there is no net loss or gain of energy. Hence, such a collision are called as perfectly elastic collision. As per as the MCQ is concerned, that question come. What is the elastic collision? Elastic collisions are nothing but such a collision in which there is no loss or gain of energy. That you have to remember. क्या होता है कि first of all I said कि gas molecules are always in the random motion. बराबर है कि वो random motion में रहते हैं, कुछ भी डायरेक्शन की जरूरत नहीं रहती है. बराबर है. एट दैट टाइम व्हाट विल हैपन, फिर डायरेक्शन चेंज कब होता है? आफ्टर द कोलिजन, कि जब वो एक दूसरे के ऊपर पटकेंगे, जब एक दूसरे के साथ टक्कर होंगी उनकी, जैसे कि आइदर मॉलिक्यूल के ऊपर पटकेंगे या दे मे स्ट्राइक टू द वॉल ऑफ द कंटेनर. एट दैट टाइम दे मे चेंज देयर डायरेक्शन. आप यारो यहाँ पे देख रहे हैं कि अगर गैस मॉलिक्यूल टकरा के गया तो वो उसकी डायरेक्शन चेंज कर सकता है. यहाँ पे एरो से इंडिकेट किया गया है कि वॉल से वो दूसरी तरफ से जा सकता है, और उसको कहते हैं हम परफेक्टली इलास्टिक कोलिजन. फिफ्थ नंबर, व्हेन द मूविंग गैस मॉलिक्यूल कोलाइड विद द वॉल ऑफ द कंटेनर, द नंबर ऑफ कोलिजन पर यूनिट एरिया डिफाइंस द प्रेशर ऑफ गैस. अभी क्या assumption है कि प्रेशर ऑफ द गैस कैसे कंसीडर करेंगे? द नंबर ऑफ कोलिजन्स. पर्टिकुलर कंटेनर में कितने कोलिजन्स ऑब्जर्व हो रहे हैं, उसके हिसाब से हम क्या बोलेंगे, वो कितना प्रेशर पे गैस है. ओके. Sixth number, moving gas molecule do not have the preferred direction. Hence, the pressure exerted by the enclosed gas is uniform throughout its volume. एनक्लोज गैस है मतलब कंटेनर में पैक किया हुआ गैस रहता है. बराबर है. अभी सबसे पहला यहाँ पे आपको नजर आ रहा है कि गैस मॉलिक्यूल रैंडमली मूव हो रहे हैं. प्रेफर्ड डायरेक्शन है नहीं। तो जो कुछ भी प्रेशर एग्जर्ट किया जाता है ओके बाय द एनक्लोज गैस, इस कंटेनर में एनक्लोज किए हुए गैस से वो यूनिफॉर्म रहता है थ्रू आउट इट्स वॉल्यूम। जितना गैस है उसके वॉल्यूम के लिए प्रेशर फिक्स रहता है। द एवरेज काइनेटिक एनर्जी, आपको पता है काइनेटिक एनर्जी कैसे दी जाती है, हाफ एम वी स्क्वायर of a gas molecule is directly proportional to the absolute temperature. These are the few assumptions of this particular kinetic theory. Just see the video. ये वीडियो विजिबल है?
In this video, we will learn about the basic assumptions which were made
Yes,
while
sir, it's
developing
visible.
kinetic theory of gases. So while developing this theory, there were some assumptions because this theory was developed for ideal gases, and we know that we don't get ideal gases in real life. So before going into the assumptions, I want to make you mean this word which is the kinetic theory, like why this is considered as the kinetic theory of gases. So the kinetic theory of gases was developed to understand thermal properties of matter. Now matter,
ले
and we know that there are three states of matter, which is solid, liquid, gas, and we
अपने होशियार
considered
बच्चे
gases because gases gases are like easy to understand. So it was seen that they saw it that as we increase the temperature, the kinetic energy also increases. So the thermal properties of gases were related to the temperature, and that temperature affected the kinetic energy of the molecules. So that's why this theory was like kinetic theory of gases. So the basic assumptions were like this. So the first assumption was the molecules of gas are identical. All molecules were identical. Like a gas consists of a loads and loads of molecules which are identical. Like there are loads and loads of balls which are identical to each other. And now let's move on to the next assumption, which is that the molecules only interact with each other when they collide. Like when there is a collision between these molecules, only then they interact with each other. So there is no intermolecular forces. And the third assumption was that the molecules were considered as hard spheres. That means that the molecules were considered as classical objects. And in classical objects, we can apply the rules of mechanics. So the molecule will undergo elastic collision, and from that we will develop our kinetic theory. So from that, if they were not considered as hard sphere or some, and in classical objects, molecules were considered as hard spheres. That means that the molecules were considered as classical objects. And in classical objects, we can apply the rules of mechanics. So the molecule will undergo elastic collision, and from that we will develop our kinetic theory. So from that, if they were not considered as hard sphere or some like atoms or something, they won't behave like classical objects, and we can't apply those rules. Now, this is kinetic theory and it has limitations, and those molecules are not classical objects. That's why these assumptions make kinetic theory a limited theory and it is not applied to real gases, but it has a significance. It tells us a lot about thermal properties of gases, especially matter. We consider them for matter, but with gases. Now, the next assumptions which were made was the molecules are equally spread, that the gas is isotropic. That means that when the gas do not have any external force, the molecules are equally spread in all the direction. And this isotropic word means that if you go in this direction, you will find
मैम सर स्क्रीन ब्रेक हो रही है.
constant at the molecules are always moving, they are always excited to move. And another assumption was this, that gravity do not affect their motion. That means that the effect of gravity on their motion is like negligible, that we do not consider in formalizing the kinetic theory of gases. Also, there was another assumption that the duration, let me use another marker for this one, the duration of the collision is very small as compared to the duration of the interval between successive collisions. And now the last assumption was all molecules do not move with same speed. Like some molecules move fast, some move slow. So these were those assumptions. If you want to note them, you can note those assumptions. And these were those assumptions which were considered while developing this kinetic theory of gases. So thanks for watching this video.
Hey, you understood this concept, kinetic theory of the gases? Some additional information was there in that particular video. That's why just I shared this video. We will see another question, that the Maxwell Boltzmann equation. Just again, I am sharing the screen. Okay, write a note on the Maxwell-Boltzmann distribution of velocity. That first assumption was there. They are not in one direction, means the gas molecules moving randomly in all direction. It is difficult to determine the speed of an individual molecule, but it is possible to work out the distribution of the molecule among the different molecular speed. And this Maxwell and Boltzmann proposed a law to correlate the molecular speed is known as the Maxwell-Boltzmann distribution law. किसे कहते हैं मैक्सवेल बोल्ट्जमैन डिस्ट्रीब्यूशन लॉ, किसे कहते हैं कि दो साइंटिस्ट है मैक्सवेल एंड बोल्ट्जमैन, इन्होंने क्या किया, एक लॉ बनाया कि मॉलिक्यूलर स्पीड को स्टडी करने के लिए, तो उसे मैक्सवेल बोल्ट्जमैन डिस्ट्रीब्यूशन लॉ कहते हैं। दिस इज द प्लॉट ऑफ मॉलिक्यूलर वेलोसिटीज। दिस ग्राफ इज शोन यूर इन योर नोट्स, आपको नोट्स लिखना है घर पे आज में। ये आपके इसमें दिया है कि आप देखेंगे यहाँ पे मॉलिक्यूलर वेलोसिटीज को प्लॉट किया है, यहाँ पे UMP1 UMP2 दिख रहा है, बराबर है। UMP is nothing but most probable velocities. UMP is the most probable velocities. This is the maximum speed possessed by the most of the molecule in the distribution curve is known as the most probable velocity. And the fraction dn by n is nothing but the fraction of the molecules having particular speed. M1, M2 are the molecular weight of the two gases. Here M1 is greater than the M2. This plot shows the distribution of speed of two gases having the molecular weight M1 and M2. UMP1, UMP2 represent most probable speed of the two gases. The speed of the gas molecule at a given temperature depends upon its molecular weight. That is, lighter the molecule move faster than the heavy molecule. ये underline करके रखना है. What is that? कि जिसका मास कम रहेगा वो फास्ट मूव हो जाएगा, जिसका मास ज्यादा रहेगा वो स्लो मूव हो जाएगा. Okay, variation of this distribution velocities with the temperature. अलग अलग टेम्परेचर है T1, T2, T3. Okay, T3 जो है वो ज्यादा है T1 से. The maximum velocities correspond to the peak of the curve at a given temperature depends upon the volume of the gas. ये important है कि वॉल्यूम के ऊपर भी डिपेंड है. As the temperature increases, height of the peak in the distribution curve decreases so that peak becomes broader. UMP is also decreases as the temperature increases. क्या है पहला ध्यान में रखना है कि करस्पॉन्ड टू द पीक ऑफ द कर्व एट अ गिवन टेम्परेचर व्हिच डिपेंड अपॉन द वॉल्यूम ऑफ द गैस. UMP possessed by the largest number of the molecule is equal to under root 2 RT by m. ये फॉर्मूला है that you have to remember. Average velocity is nothing but the arithmetic mean of the velocities of the molecule, and average velocity is nothing but under root 8 RT pi into m. रूट मीन स्क्वायर वेलोसिटी, ये आपको डिफिनेशन के लिए आता है. इट इज स्क्वायर रूट ऑफ द स्क्वायर ऑफ वेलोसिटीज ऑफ ऑल द वेलोसिटीज ऑफ द गैस. RMS वेलोसिटी इज अंडर रूट 3 RT by pi m. Relation between UMP average velocity and RMS velocity is nothing but in the ratio 1:0.9211 to 0.8165. This is the ratio for this particular what we can say molecular that UMP मतलब velocities, molecule की velocities. This is all about your this particular write a note on Maxwell Boltzmann distribution of velocity. 5 marks का क्वेश्चन है, यहाँ तक लिखना जरूरी होता है और ये बाकी का जो MCQs में आ जाता है. Okay, have you got this particular thing? This is all about your kinetic theory and the Maxwell distribution of the velocities for the gas. Okay, we will stop here.